Welcome back, 10th standard. The next question that we are going to do is question number 2 from this exercise. Question number 2 here is construct a tangent to a circle of radius 4 centimeters from a point on the concentric circle of radius 6 centimeters. So we would like to first of all draw two concentric circles, one with radius 4 centimeters and then another with radius 6 centimeters. The tangent that we want to construct will be from a point on the larger circle and it will act as tangent to the smaller circle. You have to measure the length of the tangent and also verify the measurement by actual calculation. Let us first draw the two concentric circles. Starting by taking a compass, let's fix the radius 4 centimeters. And draw a circle. Let's just change the thickness. All right. So this is a circle with radius 4 centimeters. I want another circle with the radius 6 centimeters, concentric circle. So the center of the two circles will be same, only the radius will change. Now let's fix the radius as 6 centimeters and draw another circle. Now we want to draw a circle. We want to draw a tangent to the smaller circle whose radius is 4 centimeters. If we want, we can just mark this, that this is the radius of the smaller circle and this is the radius of the larger circle. This is 6 centimeters and this is 4 centimeters. I want to draw tangents to the smaller circle from a point on this larger circle. Let's mark a point on the larger circle. I'm going to mark it a little thicker so that it is visible. So let's take this point, or let's take it here. Going over the steps to draw tangents to any circle from an external point. So this is the external point. We want to draw tangents from this external point over here to the smaller circle, and what we will do is we would first of all join this external point named P with the center of the circle. So let's join the center of the circle with the external point. The next step will be to draw a perpendicular bisector of this line segment OP. To draw the perpendicular bisector, we would like to take the help of the compass, opening the compass more than half, fixing the radius, drawing arcs from both endpoints above and below. And now we would like to finish the construction of perpendicular bisector of the line segment OP. Let's use a ruler to draw or join the points of intersection of these arcs. this point here acts as the midpoint of the line segment OP. Let's name this as M. We would like to draw a circle from this midpoint of OP. Going over the steps again, we have two concentric circles. We want to draw tangents to the smaller circle from a point on the larger circle. So point P is a point on the larger circle. This will be the external point for the smaller circle. We want to draw tangents from point P to the smaller circle. First step is to join this external point with the center of the circle for which we want to draw the tangents. Then for this line segment, we want to construct a perpendicular bisector in order to obtain the midpoint of this line segment. Once you have obtained the midpoint, from that point as center, draw a circle with the radius equal to OM or MP, or you can say draw a circle with MS center and OP as diameter. So taking the compass, placing it at point M, opening it equal to MP and then drawing a circle. The point where this circle meets your smaller circle, the one with radius 4 centimeters, those points of intersection will act as the point of contact. So this is one point of contact. Let's write with. So this will act as one point of contact. Let's name it as Q and this one as R. You will join PQ and PR and obtain tangents to the circle. This is what we have. We want to measure the lengths of PQ and PR. Then we want to verify it with actual calculation. Let's check the question again. Yes, it says measure the length and verify the measurement by actual calculation. Let's measure the length of the tangent PQ. So the length of these tangents is approximately 4.5 centimeters. Let's check for the other one as well if you can. So yes, even for the other tangent, the length is approximately 4.5 centimeters. And now we want to check this by actual calculation that whether the length should be 4.5 or not. For that, we are going to draw OQ. We are going to draw the line segment OQ. And this is a right angle. Because this is an angle in the semicircle and this here is a right triangle. I'm going to apply Pythagoras theorem. The length of OQ is 4 centimeters because this is the radius for the circle with radius smaller circle. This is the smaller one out of the two concentric circles. The length of OP is 6 centimeters and we want to find out what should be the length of QP. And since OQP is 90 degrees, we can use Pythagoras theorem in this right triangle and obtain the value for OQ. So by using Pythagoras theorem, we will have OP square equals to OQ square plus QP squared. OP is 6 and OQ is 4. From here, if we find out QP, it comes out to be 20 and the value of QP approximately is 2 root 5, and if you calculate the value for root 20 you will see that the value is close to 4.5, and that's what we obtained here.